I am still Michaela Böhnekes, and I gladly introduce our next speaker here in the studio. It is my dear colleague Markus Reichsberg with SICAM A8000 beyond the typical substation automation. Please, you already know that, I guess, type your questions during the presentation into the Q&A area, and I will answer them to Markus at the end of his presentation. And please make intensive use of this possibility, because that's your direct connection to address the expert. We both are here for you. And yes, we do record this session. Markus, I know that you would like to focus on new applications for the energy transition, and I hope that the auditorium is curious to learn about SICAM A8000 beyond the typical substation. Markus, the stage is yours.
Thank you. Yeah, my name is Markus Reichsberg, and I'm product manager for power management and principal key expert for microgrids and distributed energy systems. In the next minutes, I would like to give you some insights into SICAM A8000 beyond the typical substation automation. This means I would like to show you what you can do with SICAM A8000 in the field of energy transition, counteracting to climate change and its associated challenges. In this regard, I would like to present you first the environment the applications are directed to, before I start to give you more details on 3 examples: microgrid control, load shedding, and photovoltaic plant control. I'll briefly explain for each application the use cases and benefits, and will also indicate one project as a practical example for better understanding of the topic. My presentation concludes with the underlying system architecture, which is of course common for all 3 applications, to illustrate in more detail the used components of the SICAM A8000 family. This sequence is intentional, as I would like to focus on customer value first. As already indicated by the title of the session, a large portion of the energy transition is happening at the grid edge. This means not only transmission and distribution system operators are affected, but also the consumer side and the energy production side. If I talk about consumers, I'm rather talking about large consumers like industrial sites, campuses, or infrastructures, and explicitly not about residentials. As we all see in the challenge meeting CO2 targets and avoiding related costs imposed by regulatory bodies, laws, or resulting energy price development, most energy consumers are striving for better energy efficiency, sustainability, and reliability. Also, or especially regarding energy cost. Looking in more detail in the so-called grid edge, we immediately see a certain variety of topics on the table. First, the energy production by renewables, mainly wind and solar. Is it central in case of large photovoltaic and wind parks, or decentral on customer premises? Second, as these renewables are typically fluctuating due to weather conditions, energy storage systems become more and more important. And another trend is obvious. If we use the term energy, it does not only refer to electricity anymore, but we are also talking about thermal demands and H2, sometimes also referred as power to heat or sector coupling. Not to forget one important rapidly growing aspect, the electromobility. Out of this playing field, I would like to address 2 specific topics: microgrid and industrial grids as a bridge between supply and demand side, integrating renewables, storage systems, and electromobility, and photovoltaic plants as a pillar of a green, sustainable energy production. The first topic I would like to look into is microgrid control. What is a microgrid? A microgrid is typically a small electrical grid. Is it an industrial site, a commercial or university campus, or a military base? It owns energy production assets, typically renewables, but also conventional systems like diesel engines, gas turbines, and CHPs, and also includes storage systems and, of course, a variety of loads. Such grids, which may under certain conditions also be operated independently from the main grid, typically range from 1 to 500 megawatt. Means from a small campus site to a mine or an oil refinery. The task of the SICAM A8000 microgrid control application is threefold. Typically, own generation is maximized while ensuring continuous load supply and production processes, also in case of grid outages. Second, microgrid control orchestrates generation and loads in a way to minimize energy cost by economic optimization between main grid supply and local generation, also considering actual energy market prices. And third, it also strives for decreasing CO2 emissions by optimizing the use of renewable versus fossil generation. To do this, the SICAM A8000 microgrid control provides basic features like monitoring, reporting, archiving, and control, but also advanced features as automatic islanding and black start, peak shaving, load management, load and generation forecasting, and an energy, respectively, ancillary services market interface. A good example is our project Lemene in Finland. This is a commercial campus with about 20 megawatt local generation based on gas-fired CHPs, boilers, and 4 megawatt of photovoltaic systems, covering the electrical and thermal demand. It is typically connected to the Finnish grid with fully automatic access to the Nord Pool energy market and the FinGrid ancillary services market, which is mainly served by the two 1.5 megawatt battery storage systems. However, there were also several occurrences where the Lemene microgrid automatically disconnected from the outage power grid and ensured uninterrupted supply of the site. All happening fully automatically without any user intervention. While in the case before, the site's generation assets typically provide enough operating reserve to handle unexpected loss of generation, as there are many smaller ones, there are also other scenarios where further actions are required to ensure grid stability and continuous supply. Here our load shedding application comes into the game. Fast or dynamic load shedding is typically used in large industrial grids with single generators in a multi-megawatt range. It supervises on the one hand side the electric generation or grid in-feed, while on the other side it continuously is monitoring the load's demand. The target is to ensure continuous balance of power, means if, for example, one generator trips, it immediately sheds the equivalent amount of load. All happening within maximum 70 milliseconds using IC61850 Goose communication. The load shedding can be fully integrated with the generation control HMI to provide an overspanning power management system. The SICAM A8000 load shedding application supports, besides the basic features, fast, dynamic, and frequency-based load shedding for up to 600 loads. A good example for load shedding is the Hyundai Steel plant in South Korea. There, we combined our SICAM A8000 load shedding application with Cyprotec 4 and Cyprotec 5 IEDs to automate shedding of around 80 loads, considering 30 contingencies, means 30 different scenarios of loss of their 4 gas and steam turbines and their 2 incomers. The last topic I would like to present is our SICAM A8000 photovoltaic plant control application. The control of a photovoltaic plant is a little bit different than a conventional plant. Instead of communicating to one turbine or a single engine, you must orchestrate a multitude of inverters to ensure a grid code compliant behavior of the plant at the point of connection to the transmission or distribution grid. And as the power production might fluctuate over the day depending on solar irradiance, also battery storage systems and capacitor banks are sometimes integrated to ensure proper reaction on active and reactive power demands. Therefore, our SICAM A8000 based photovoltaic plant control application is not only able to perform real-time grid code compliant active and reactive power control, but also integrates with weather forecasting applications. Grid code compliance is a must, but the money is made with energy. As an example, I selected the world's largest floating solar power farm at Sirindhorn Dam in Thailand, where we combined our SICAM A8000 photovoltaic plant control application, mastering the 45 megawatt floating photovoltaics with our Microgrid control application, pooling it with the 36 megawatt hydropower plant. So far, I talked a lot about the use cases of our applications, but how they are implemented on A8000, which SICAM A8000 devices are supported, and how they are positioned within the SICAM product family. All 3 applications with their standardized IC and IEEE conform logic are running on SICAM A8000 CP8050 or CB8031. As we strive for an open system architecture, allowing project-specific configurations, following aspects are important. At first, the logic is implemented on CIX Plus using SICAM Toolbox 2, allowing full access for engineering and commissioning. An important aspect, as no site looks the same as the other. Second, all important information is available within the SICAM A8000 dashboard, sometimes also referred as integrated HMI, so that our A8000 application can be connected to any Siemens or third-party HMI system if required. And third, we provide a fully pre-configured HMI system based on SICAM SCC, which can of course be adapted and amended according to customer needs. So either you can take the applications as they are and just configure and commission them in short time, or you can also adapt them to your project needs. A lot of theory. So here an example of the Microgrid control single line dashboard as provided by SICAM A8000 CB8050. And a similar HMI screen of the more powerful SICAM SCC based HMI. So to sum up, SICAM A8000, CB8031 and CB8050 are a solid base for fostering energy efficiency, sustainability and reliability. They provide a variety of ready-to-use applications and features beyond the typical substation automation you might be aware of. Due to the openness of the SICAM A8000 and the supported communication protocols, you can flexibly integrate with equipment outside the substation automation environment, like generators, battery storage systems, and photovoltaic inverters. Using the SICAM A8000 engineering tools, the openness of the system allows you to also integrate proprietary logic at any time. Thanks a lot for your time and interest.
Thank you, Markus. Some more insights into SICAM A8000 and its application possibility. And we have some questions from the auditorium. So the first question that came in is, can A8050 replace an AK3 completely in industrial applications?
Yes, and CP8050 can replace the AK3 in all industrial applications. Means we are already delivering since more or less 1 year the majority of projects already based on CP8050.
Oh, okay. Thanks. And the next question is, at what time scale do you support for the load shedding application? Do you need to define it first with the client?
There is a certain amount of questions you have to clarify upfront with the client. Means the rough configurations, the communication architecture, the amount of loads and the algorithms. This has to be done upfront. Typically, other clarifications are done in the course of the project.
Okay.
That's normal. It's a solution and system business.
Yeah. Start and clarify and detail.
Right.
And yeah, I think I remember that. And then we have another question concerning the interesting thing around e-cars. GB wants to know, does your microgrid control solution also support load management of e-car charging posts?
Yeah, we also lately included the management of e-car charging posts, and we offer this also as a separate application, so you don't need the full microgrid implementation. You have a separate implementation only for e-car charging posts, which can then be also combined with the microgrid control solution.
Okay, I see. Thanks a lot. And we take at least one more question. Oh, do the applications only work with Siemens assets?
No. As we strive, as said, for an open system architecture, we typically connect to non-Siemens assets. So only prerequisite is we need a common communication interface, like Modbus, for example.
Okay, yeah, that sounds feasible. And we have one last question in the row. Which are the typical market segments that are addressed with this load shedding solution?
Yeah, for the load shedding solution, we are typically addressing oil and gas customers, large customers like refineries, but also food and beverage, for example.
Oh, okay, thanks. So I don't see any more questions in the row right now, but no problem. If answers come to you later, we are still there. You can either contact us via any kind of contact medium, like our web pages, like LinkedIn, like things like that, or even better, chat and talk to our experts. In the exhibition area of this World of Electrification and Automation, you find this button, Let's Meet via Teams. And that's exactly where you meet our experts and can go into a one-on-one discussion. It's not like typing a question here, but really people behind it. Markus is right now here on stage. I'm not sure, will you be in the chat with other experts? So you will be there, but we have even more experts talking about SICAM solutions, talking about microgrid solutions. So just visit the exhibition. That was how to address questions to us. I think I already mentioned, we recorded the session. It will be made available to you so you can view it again if you like the presentation. And I'm now looking forward to seeing you even in one of our next sessions. We will have 2 how-to sessions. In about 15, no, I think it's now in about 20 minutes. My next conference speaker here will be again Jorge Diaz, and he will present a how-to session on SIAP. Until then, thank you, Markus, for being here, for presenting the SICAM A8000 way beyond the typical substation automation. Thank you out there for your questions, for taking time and spending it with us. Take care and goodbye for now.
Right.